Here we're looking at some more probability rules, concepts and methods. So last time we did already look at the idea of two mutually exclusive events, things that cannot happen together. And we did see as well that if you have two mutually exclusive events, you can add together their probabilities to work out the chance of either one of them happening. So I'm just going to revise that with the idea of a coin here. So you know that if you flip a coin, you've got a 1/2 chance of getting heads and a 1/2 chance of getting tails. Those two events are mutually exclusive. You can't get both a heads and a tails in the same flip. So if you were to ask the question, what's the probability of getting a heads or a tails, like this, the OR rule says well, you'd add those two together. So you'd do 1/2 plus 1/2, which is going to be 1/2. And that does make sense. What's the chance of getting a heads or a tails? Well, it's certain. You're definitely going to get at least one of those things. So this is the way that I remember what the OR rule is. I know that 1/2 plus 1/2 is 1. A heads or a tails on a coin is certain. There's another concept we need to be aware of, which is the phrase independent event. So independent events are events that do not affect each other. And the coin toss is a good example of this as well. If you flip a coin and you get a tails, the chance of getting a tails again is exactly the same. It doesn't matter what happened before. People get this wrong all the time. They have something called a hot streak fallacy, thinking, oh, it's been tails 5 times in a row, it's definitely going to be heads next time. It doesn't make any difference. It doesn't matter what happened before, the new coin toss is exactly the same probability. That's because those are independent events. They don't affect each other. We are going to look at some events later on in this video that are not independent, so look out for those. We have, as well as the OR rule, the AND rule. And this is saying that if you want two events to both happen, then you're going to multiply the probabilities together. So we use the coin again to show that. If I want to find the probability of getting a tails and a tails, I'm going to multiply those two probabilities together. So we know that's going to be 1/2 times 1/2, which is going to be 1/4, times the top together, times the bottom together, and then you get that answer. You can see this is true because if you list out all the possibilities from flipping a coin twice, you get tails, tails, you get tails, heads, you get heads, tails, and you get heads, heads. 4 possibilities, one of which was the one we wanted. So there's a 1 in 4 chance of this happening, which is what you get from multiplying with the AND rule. So tails and tails, 1/2 multiplied by 1/2, 1/4. So we'll look at these set of rules and ideas in a slightly more complicated scenario. So just looking around the house again, limited with teaching materials, but I've gone to the bookcase and I've found 3 categories of books here. Hopefully we can see these. Right, so these are the categories. I've got some Shakespeare, some books in Italian, including Harry Potter e la Pietra Filosofale, and 1 history book. So it's pretty easy to work out what the chance of me choosing any individual one of those books is. It's these: 6 out of 11, 4 out of 11, and 1 out of 11. We can use the rules we've just looked at to work out some more complicated probabilities. So what is the probability of me choosing a Shakespeare book or an Italian book? Now in this situation I'm talking about choosing one book to read now. I can't read 2 at once, I can't choose 2 at once. So these are mutually exclusive events. I'm going to pick just one, and in that case we're going to take the 2 probabilities of the Shakespeare and the Italian and we're going to add them together. So in this case the calculation is going to be 6 out of 11 plus 4 out of 11. That's going to give me 10 out of 11, which looking at the pile makes sense because I'm really just choosing from this and this together out of a total of 11. So the 10 out of 11 makes sense. That's the OR rule. Probability of choosing Shakespeare and Italian. Right, so in this situation I'm talking about choosing one book to read today and then the next day coming back and choosing another one. So these are 2 consecutive events. Now we're going to use the AND rule, so we're going to multiply two probabilities here, but this is an example of when the events are not independent. So my choice initially, as you can see, is going to be out of this lot, it's going to be a 6 out of 11 chance of choosing the Shakespeare. I'm going to multiply that by the chance of choosing an Italian book, but of course I don't want to read the same book twice. So once I've picked this one and taken it out, my choice now is not out of the same as it was before. In fact, my chance of choosing an Italian book now is 4 out of 10. Because there's now just 10 books. There's still 4 Italian ones, but there's now just 10 of those. So if we multiply these two together, we get 24 over 110. Look at the last one here. Probability of me choosing a history book and a history book. Let's put the Shakespeare one back in the pile so it's the same as before. Well, you can see the chance of choosing a history book is 1 out of 11. But again, if I make that choice, take that away and read that, when I come back the next day for my second choice, I've got a 0 chance of choosing history because there's now none there. You could write 0 out of 10, but that doesn't really make any sense. We're just going to put 0 here. And that means that, well, anything times 0 is 0. So the probability of me choosing a history book and a history book is 0, i.e. it's impossible. Which does make sense, because I can make that choice the first day, but the second day, I can't. So that's the OR rule and the AND rule. There's one situation in which these get used a lot, which is in tree diagrams. So we're going to finish by looking at a tree diagram situation here. Now I'm going to simplify this so I don't have to do such a big tree diagram. You can do tree diagrams with 3 branches or 4 branches or a million branches, but these whiteboards aren't really big enough. So I'm just going to simplify this by just having these books now, taking out the history book. So we've got 6 Shakespeare, 4 Italian. And I'm going to make the tree diagram to basically show all the things that could possibly happen in this scenario. So the branches here represent the choices I can make at each stage. So initially I've got a 6 in 10 chance of choosing the Shakespeare, I've got a 4 in 10 chance of choosing the Italian. That's pretty straightforward. But of course things change depending on what happened before. So if I'm now going to choose a Shakespeare and then come back for a second book, I've still got 2 choices, but they're not the same as before. If I've chosen the Shakespeare, my second Shakespeare choice is going to be 5 out of 9. But my Italian choice is still going to be 4, but in this case it's going to be out of 9. The reason why we have a tree diagram is because the branches down here are going to show a different reality. Like imagine we went back and actually initially we didn't choose Shakespeare, we chose Italian instead. The 2 branches here are going to be different to the 2 branches here. That's because these are not independent. Sometimes the branches here will be the same as the branches here. It depends on the scenario. So in this case, we choose an Italian book and then we go for a Shakespeare. Well, there's still going to be 6 of them, but it's going to be out of 9 because one of these is gone. And down here, for our Italian book, we have a choice of just 3 of these now out of 9. So that's the tree diagram complete. Make sure you can see all that. Now, one thing I would urge you to do in all tree diagram questions is work out every possibility at the end of the branches. So this one here is Shakespeare and Shakespeare. That means we're going to multiply the probabilities. We're going to do this times this. So we're going to get 30 out of 90. And for once, I'm going to say don't simplify this fraction. There's a good reason for that, which I'll mention later. So I'll leave that as that. Then we're going to do Shakespeare and Italian, so that's going to be that times that, so 24 over 90. Italian and Shakespeare, it's actually going to be the same thing. And Italian, 4, 3, so it's going to be 12 over 90. Good little check at this point, we should have covered every possible outcome. So if we add all these together and say this or this or this or this, using the OR rule, we should get 1. So 30 plus 24 plus 24 plus 12, that does make 90 over 90, which is the same as 1. Therefore, we've covered everything. It's going to be certain to be at least this or this or this or this. we're actually going to try and work out these particular questions based on our tree diagram. So let's look at the question here. Probability of Shakespeare and Shakespeare. That's easy because I've already got that. That's going to be 30 out of 90. I've already found that from the tree diagram, so I'll just put that straight in there. At this point, you could simplify it, especially if the question asks you to do that, and that's going to be 3 over 9, which is going to be 1/3. Now, the reason I said don't simplify is because of a question like this. What's the chance of getting 2 different books? So there's different ways that can happen. We could get Shakespeare and Italian, so we would need this one, but also we could do Italian and Shakespeare, so we need this one as well. So that means we're going to add these 2 together because this or this, that's both good. So let's put these in here. So it's 24 over 90 plus 24 over 90. And here's why you don't simplify. They've kept the same denominators, so they're very easy to add now. So 48 over 90 is our answer. Again, you can simplify that. I'm not going to bother because I've run out of space, but you can do that, I'm sure. Last question, at least one Italian book. So again, if we go through and mark off the ones we're interested in, well, Italian, that's definitely at least one Italian book. Italian Shakespeare, that's at least one Italian book. Shakespeare Italian, so is that. But the only one that's not is this last one here, Shakespeare. So it's adding these 3 together. So this plus this plus this. Or another way of doing it would be to take 1 and subtract that away from it. Either way, you're going to get the same answer. I'll just do the adding version because it's most consistent, I think. So we've got 12 over 90 plus 24 over 90 plus 24 over 90, and that gives us 60 over 90. Well, that's not how to write. 60 over 90. And again, you can simplify that quite easily, 2/3 in this case. We would have got the same answer by doing 1, subtract that. Okay, should be enough to be able to answer some of those tree diagram questions, so good luck with that.